In this video, we are going to talk about forward difference table. So from the given data points, we will construct our forward difference table. First, we will construct our general table, and after that, we will look at a particular data with numbers. Let's say we have the data consisting of 3 points. And this data is equally spaced. From the previous videos, you can recall that if the data is equally spaced, then the difference between every two consecutive values is same all along the data. And let's say if x0 is the first value, then the next value would be x0 plus h. Then the next value would be x0 plus 2h. Then the next value would be x0 plus 3h. So if your first value is x0, then the next value which you obtain by adding h into the previous value, so it is also written as x1. So you can read x1 as x0 plus 1 into h. Next value is x2, which can also be read as x0 plus 2h. Next is x3, which can be read as x0 plus 3h. So whenever the data is equally spaced, we write each xn is obtained by adding x0 into nh. So this is for equally spaced data. Okay, so we have 3 points data and we have to construct forward difference table. So first we will write the data in tabular form: x0, x1, x2, y0, y1, y2. Now to construct the forward difference table, what you have to do is put an arrow between two y values and calculate the difference between these two values. But remember that you always have to calculate the difference second value minus first, means y1 minus y0. It should not be y0 minus y1. Now you put an arrow between the next two values, next two y values, and calculate the difference between these two values, y2 minus y1. Now you can also put an arrow between these two values, so it is second value minus first. Here the second value is y2 minus y1 minus the first value is y1 minus y0, because the arrow is in between y2 minus y1 and y1 minus y0. Simplify this and it becomes y2 minus 2y1 plus y0. So we have constructed a forward difference table. It's just about calculating the differences. But now we have to name the columns and put the notations of these values that we have got. So first of all, we are going to name this third column as forward operator yk. And the next column, we are going to name it as forward square yk. You will see that why we have named the third column forward power 1 yk and the next column forward power square yk. Now please look at this term, y1 minus y0. If you can recall the definition of forward operator, y1 minus y0 actually is the definition of forward operator acting on y0, because let's have a look at forward operator acting on y0 again. So when forward operator acts on y0, it jumps to the very next value. The next value after y0 is y1 minus it calculates the difference with itself, which is y0. So we can see that the first value in the third column is actually forward y0. So this is the notation of this term which you have calculated by subtracting y0 from y1. And the next value, which is y2 minus y1, it is actually the definition of forward y1. So first forward y0 and next value is forward y1. It means you are increasing the subscripts. So let's put the notation now for the third column value y2 minus 2y1 plus y0. We have calculated this difference, but we just want to name this term y2 minus 2y1 plus y0. Now let's do some calculation. If you are asked to calculate forward square y0, so how do you do that? You keep one forward delta out, one forward in. So first you solve the inside part. Forward y0 is y1 minus y0 by definition. Then apply the forward inside. Forward y1 minus forward y0. Forward y1 by definition is y2 minus y1 minus forward y0 definition is y1 minus y0. So we have y2 minus 2y1 plus y0, and this is actually the definition of forward square y0. Now let's look at the forward difference table that we have just constructed. Here y2 minus 2y1 plus y0, this term is nothing but forward square y0 that we have just calculated here. So it's forward square y0. So you can see that in the fourth column that the value you got was obtained by making the difference forward y1 minus forward y0, or it was calculated as the difference y2 minus y1 minus y1 minus y0. And now we have seen that this term y2 minus 2y1 plus y0 is actually equal to forward square y0. When we expand forward square y0, we get y2 minus 2y1 plus y0. So let's have a look at the forward difference table again. So we had the xy data x0, x1, x2, y0, y1, y2, and we calculated the next column. It was forward power 1 yk column. So the first difference that you calculated for the third column was y1 minus y0, and you named it forward y0. The next difference you calculated as y2 minus y1, and you named it as forward y1. Now you construct the next column, which is going to be named as forward square yk. Now every value in this fourth column will have the notation forward square. That's why the name is forward square. And you have two values. You put an arrow between these two values and calculate the difference. And when you calculate forward y1 minus forward y0, the notation of this difference is actually forward square y0. So you can see that in the column y, forward yk and forward square yk, the first values are y0, forward y0, forward square y0. So this is how we construct a forward difference table. Let's construct a forward difference table for our data. Let's say we have an equally spaced data 2, 4, 6, and y values are -1, 0, 7. We'll name the columns later, but let's quickly construct the table. You put an arrow between these two values, second value minus first value. 0 minus -1, it is 1. Arrow between these two values, calculate the difference. 7 minus 0, which is just 7. You got two values, you put an arrow between them and calculate the difference. 7 minus 1, which is 6. So that's how simply we can calculate the forward difference table. But now let's name the table. This is forward yk column. This is forward square yk column. Name the values. This is x0, x1, x2, y0, y1, y2. In the third column, forward yk, the first value is forward power 1, because this is forward yk column. Just 1 is the power on forward. So all values in this column will have the notation forward power 1. Forward y0. This is the notation of this difference. Next value is forward y1. Now in the fourth column, the first value is 6. It's actually the only value. So the notation for this 6 is, it is forward square, because it's a forward square yk column, forward square and y0. So this is how we can construct the forward difference table in few minutes. Let's very quickly construct another forward difference table. We have an equally spaced data 3, 5, 7, 1, 4, 3. So first name the data: x0, x1, x2, y0, y1, y2, forward yk column, forward square yk column. Let's make the table. 4 minus 1, 3, 3 minus 4, minus 1, minus 1 minus 3, minus 4. And just name the values. It's a forward yk column, so forward, the first value is y0. Next is forward y1. The fourth column is forward square yk. The first value is forward square and then y0. So that's how we construct the forward difference table. In the next video, we are going to construct a backward difference table.